Welcome back, everyone. So I would like to introduce our next speaker. Just not to make a mistake, let's check the program again. Yeah, the next speaker is Swain. He will show us the tools, the technology, and the techniques that he used to build environments in Gloomhaven, which is a board game adaptation. A large chunk of this talk will be a live demo. So huge thanks to Sam for preparing this, because live demos, they're interesting, but also they take a lot of practice and nerve to get right. So buckle up. I think that we are ready to go.
Hi,
Sam?
I don't seem to have a camera at the moment. Can you hear me all right?
We can hear you well.
Okay, good. Yeah, I don't think I've got my camera working. I might just have to screen share at the moment. Okay, hopefully you can see the screen.
We can see the screen well.
And you can hear me, that's good. That'll have to do. It's always the way. Thank you very much for having me. I've got a bit of a cough, so hopefully that's not going to interfere with the presentation, but we'll see how it goes. All right, hello everyone. My name is Sam Swain. I've been working in the video games industry for over 25 years, most notably perhaps on a number of games in the Fable franchise at my time at Lionhead Studios. Today I'm going to be talking about the procedural techniques we use to build the environments for the digital adaptation of the board game Gloomhaven. Gloomhaven is a tactical combat board game with players working together to vanquish menacing dungeons and forgotten ruins. It involves card play, strategy, and cooperation. The action is played out in a series of hex-based map tiles interconnected to form weaving dungeons with open spaces and narrow corridors. Each scenario has a particular room layout, rules, and risks and rewards for the players. It was a huge undertaking to create the whole game, with nearly 100 bespoke campaign scenarios, dozens of characters, hundreds of cards, and thousands of rules to adhere to. To build it all in one go was too much of a developmental risk, and the team at Flaming Fowl decided to approach it from a different direction. Starting with a subset of the whole game, they planned on leveraging various procedural techniques to build an adventure mode version of the game, which mixed together the available elements into randomized scenario encounters set across a generated map. This approach meant that they could enter early access with a much smaller and more manageable set of assets and features, yet still bring the true Gloomhaven gameplay experience from the start. The dynamic nature of parameterized procedural systems was ideal for coping with the unknowns of populating an endless variety of map tile configurations and interconnections that just wouldn't be possible by hand. As development progressed, they were able to build on the core adventure game with more biomes and themes, more characters, more enemies, and increasing visual richness and finesse. And once the full set of assets was available, they could then start building the set of campaign scenarios present in the board game, knowing that they had a solid game with all the tools and technology in place and a large community providing valuable feedback along the way. The pipeline for building the map is a hybrid of configuration data, code, data-driven procedures, and artist-created content palettes, each chosen according to their strengths and the constraints and requirements of each part of the process. The scenario design, map layout, and map tile analysis is all performed in code, written by the gameplay team according to the game's requirements for mission structure and gameplay rules. My involvement starts at the map tile analysis stage, and the rest of the talk will be on the way these layouts were turned into the actual placed meshes and prefabs that form the environment the game plays out in. The map tile walls are processed as a whole to allow for room-to-room obstruction to be taken into account, and the available space assigned to the walls to allow for features that extend away from the play space. Each map tile comprises a number of separate pieces contributing to the scene, to the variety of elements in the scene. The larger pieces, the floor, the walls, the doorways, are each handled by their own generation procedure, implemented using a proprietary system called apparents. Apparents is a toolset and technology I've been building for a number of years and more recently integrating into Unity. It's a procedural synthesis engine for building parameterized composite objects and geometry at runtime. It's fully data-driven and general purpose with its own interactive node-based editor. The team at Flaming Fowl decided it was a good fit for the complex and dynamic nature of what they were trying to achieve. It is this that handles turning the floors, walls, and doors into actual placed assets in the Unity scene. So let's switch over to Unity to see some of this in action. So let's have a bit of a live demo. Oops, yeah, there we go. Okay, so this is the, first we'll look at just the floor grid. So this is built to populate a given area with hexagonal tiles for the gameplay to occur in. This test procedure is parameterized by the region to fill, so the width of the area and the height of the area, as well as a seed value for variation and changing placement decisions. If I just leave that over there for a second. If I now switch to the appearance editor and open up this procedure. So we can have a look through some of the procedures involved. This top level procedure acts as a test jig, setting up some default inputs for the actual grid procedure. By opening each sub procedure, these gray nodes, we can dig down through the hierarchy a bit, past alignment and rounding calculations, the tile grid row and column iteration, tile selection in here. So there's tile selection logic largely based on the input styling parameters, some pattern selection logic, until finally we reach the final lookup and instancing of the tile asset by these fundamental operators, these black nodes, which are responsible for placing the actual mesh in the scene. Some floor types have special handling logic. This crypt style has the worn tiles in the middle and sort of the less damaged ones further towards the outside. And if I go back to the top here and do this, we can see that this is another example of a different look. This is the sort of ruined style. So this ruined biome has some custom logic to produce this uneven floor effect. If I do this, we can have a look and see. So this is introduced selectively here. And if we dig in, I can demonstrate some of the interactivity features. Here we can adjust the range of, the probability that a tile is angled, and then we can tweak the angle values to see them changing as we like. Obviously, you probably wouldn't have it as extreme as this, but it's easy to play with the node graph and the values until you have a look that you're happy with. Now we're going to have a quick, we'll go back to the, we're going to go back to this test scenario here. So this is an example of an actual map. But first we'll look at, there we go, that's next page, yes. So next we're going to have a look at how the walls are constructed. So if I select this back wall here and move it away, you can see how it dynamically adjusts the tile pieces used at its base to fill in the space between it and the adjacent hole tiles of the hex grid. The walls on this hex grid have two main orientations along the points of a hexagon. And if I turn it around, we can see along the flats of the hexagons as well. Like the floor, each wall is parameterized by its size, so we can adjust the size or the length of wall, the space it's going to occupy, and also they're seeded by as a seed value for bring variety to each individual wall. Being able to interactively scrub through parameter space like this is invaluable working with generative systems, I find, where there's no easy way to test all of the possible outputs. So rapid previewing of results like this allows almost a statistical approach. You can rapidly show up problems where some cases are just not handled properly on break, or are just not meeting some sort of aesthetic requirement. Walls are composed of modular pieces. So we have the flat and decorated. We've got hex-aligned pieces and even little prefab vignettes set in their own walled areas. So by gradually adding more possible alternatives to both the wall construction logic and the base assets available, you introduce more layers of variety. The more you add, the more axes of parameterization are built in, the more ways they can interact, and the richness of the results of it and interesting combinations you can discover expands into a sort of huge aesthetic space. So let's look at the procedures driving these walls a little bit. I'll go back to the editor here. If I open this one. So digging into this top level wrapper, we can see the main wall procedure. Obviously, there's quite a lot going on in this one, from grid snapping to alignment to wall surface bounds calculation, floor edge tile generation, wall feature insertion, the main linear section of the wall, surface features, foundations underground, and some clutter as well in the corners of the rooms. If I go into here, so to aid the development process, excuse me, at various stages, diagnostics displays were built into the procedures to help visualize many aspects of the systems and parameters at play. So, for example, if I go back out here, turn these on. If I switch this on, we can see each room's driving parameters shown in world. If I turn on this one, we can see map tile bounds, areas, and tile coverage information. And this one. And here we see wall surface spaces. These are slots in the walls and pillars and alcoves for decorative elements to go in. These are particularly important because light sources are managed by a quota system where the calculated ideal number of lights for a room is passed down and distributed through the procedural elements for placement, taking priority over decorative items. If we take another look at this back wall, let me just turn those off. If we take a look at the back wall again, you can see it's been delegated to provide 2 torches to contribute to the room lighting. And so regardless of the length of the wall, it tries to maintain that distribution along the wall length. Let me just move this wall back. There are many tile-based props in the game, like obstacles, treasure chests, traps, and difficult terrain. These have code to inject their presence into the floor and wall procedures and parameter inputs. A list of tile exclusions that then block the generation to leave space for them. Doorways do the same thing. So if I take this door, and then the main reason we need the procedural logic when building the walls is they add to the complexity of populating the map tile boundaries. So we can move a door like this one, and the surrounding objects rebuild to accommodate it. And you can see as it updates the excluded tiles here as well. As we've seen, there are many assets, art assets that contribute to the makeup of each piece of scenery. If I go to here and have a quick look in here, here's some example. We'll look at some examples of how they're set up and consumed. So here we've got some wall sections, some hexagonal map tile variants, some pillar variants, some of the hexagonal aligned features, and some examples of little prefab vignettes that appear in the walled bays when there's space available behind a wall. So we're looking at the project here. We can see, if I dig into this, we can see these are where the assets are added to these resource lists, such as this one for the bays in the crypt biome. And these are then picked from by the procedures at random and according to criteria like space available. Now that most of the procedural tech is set up, the process of expanding the visual styles in the game is largely down to the art team adding more and more to these lists. Let's head back to our main scene. Okay, so the visual styling of scenarios is divided into several categories, mainly this biome and then the theme, and then some subcategorization as well. The biome controls the overall look and style and structural elements of the map. So for example, if I switch, we can see sort of dungeon style scenery. We've also got a cave. Forest, and a city setting as well. The sub-biome provides specific customizations to the biomes in some cases, like these city streets, which have got an upper floor on as well. So let's go back to our, there's under crypt, there's a couple more as well, have a quick look at. This is the ruined floor that you saw earlier. So themes are used to illustrate the purpose of a room. So to provide more detail and override a few things. So for example, if we look at this case here of a library, we now have bookcases and books strewn all over the floors. Seeding of procedures is important for a variety of reasons. So the variety of the room is controlled by this root seed here, which is propagated down through the object hierarchy, and then the procedural hierarchy as well to affect asset selection, decision making, and value selection all over the place. As we change the main seed, all of the systems regenerate their elements to have a new appearance. Okay, so that covers most of the process and pipeline. So I'm going to finish with an overview of some of the things we learned and benefited from that hopefully will be useful takeaways for you. The team found that a hybrid approach worked best for them. So code is good for analysis and number crunching. Procedures are good for logic, layout, 3D construction, and particularly visual work. And sometimes handmade, highly bespoke pieces or systems are what you'll need instead. And the layering of these approaches and systems allows you to benefit from the increasing ways that they can all interact. Procedural generation of worlds can get you moving and exploring a game's design space quickly, offering ways to rapidly create a variety of content, rapidly create quantity of content, and provide an early approximation of the full-scale game experience. As an optional bonus, this can give you the option of an endless play capability if that's a fit for your game. To progress effectively, it helps to start out basic, get the game and its principles working first, so that everyone can then proceed to enhance systems, add variety, and scale quantity of content, letting this happen in parallel, not serially, i.e. you're reducing the dependencies on people waiting for one part to be fully finished before the next stage. Leveraging of modular asset collections means changes will improve all scenes or levels and make improvements to a generative system, and the benefits ripple across the whole game. Originally, the bespoke board campaign was going to be built by hand. The adventure mode opened up possibilities and allowed the potential of procedural generation's power to show through. Increased confidence allowed shifting to mostly generated campaign scenarios, reusing the adventure mode systems. An in-game editing tool for building scenarios at a high level gave art the control they needed. Tuning via selection of seed values, the addition of custom map tiles, and a few bespoke assets like obstacles and props This became a most welcome time saving for this later part of the project. And although comprehensive modding support was planned from the start, the in-game editor became another tool for players to use too. Dynamic procedural systems can adjust to accommodate infinitely varying inputs, from fitting into an arbitrary space intelligently to the effects of changing a seed value rippling down through a deep logic and calculation hierarchy. Even if you don't set out to have infinite levels, dynamic interactive assets adjust to fit variable needs, aid rapid design iteration, facilitate play and discovery, and cope with changing requirements. Parameterization by style, referencing palettes of assets, allows reskinning of scenery and constructions. This can provide additional depth, richness, and variety for the player. It can allow content creators to tackle the problem in parallel. Reuse of already built parts with a new look can save time, and it's an easy entry point for artists not needing to touch code or script. Interactive editing is a great tool for developing complex and visual layout problems, scrubbing values to cover large areas of parameter space and spot problem areas rapidly, assess behavior stochastically rather than with one or two slow to evaluate test cases, easy to add diagnostic tools and data visualizations using the same systems, get your objects to tell you what's going on. It's not rare for a game with some pretty basic premises, such as being built on a hexagonal grid, to turn out to have many tricky and unexpected corner cases, both figuratively and literally. You can't avoid having to do the hard work of understanding and implementing some complex systems. Node graphs have a bit of a bad reputation with large systems, particularly with the visual noise large graphs can end up with. I believe this is largely a tooling problem, and investment is needed to provide ways to easily manage and encourage the use of deep hierarchies, functional modularity, and of reuse, all essential in tackling this. The parametric and deterministic nature of self-contained procedures or procedural hierarchies allows parts to be tested in isolation. Feeding test inputs using a test rig wrapper and perhaps visualizing the results graphically, you can both validate the operation and explore the subset of parameter space separately from the enclosing higher level procedures. And finally, I found that inline comments, labels, and descriptions help organization where an individual procedure is naturally handling a large piece of functionality. Okay, I hope that all made some sense. These slides should be publicly available at some point, so you can look through them in more detail. The Gloomhaven game is in early access. Check it out on Steam if you're interested in this genre of game or a fan of the board game. Apparence is an ongoing project of mine, started because I wanted to make games in a particular way and that did away with some of the traditional asset pipeline. It's primarily a Unity plugin, but thanks to an Epic Mega Grant, I'm in the process of porting it to Unreal as well. Although I'm only working with direct licensees and evaluations at the moment, this boost will also help advance towards the planned public release in the future on Marketplace and Asset Store. Here are some contact points if you want to find out more about myself, Apparence, or Gloomhaven. I hope you found this talk interesting and useful. I look forward to your feedback and thoughts. And once again, many thanks to Everything Procedural for having me this year, and thanks for you for watching. I think hopefully we're going to go to some questions. I might try and get my camera working as well. I believe it's probably.
Thank you very much, Sam.
Hopefully that
was a lovely session. You can.
Hopefully that all came across. It's difficult to tell when I'm just isolated like that.
Yeah, doing everything through the wire, definitely.
Yeah,
but we are looking at the chat, and the chat is exploding, so that's good. And I think it was a clear explanation, and I really like the balance that you had between the live demo and just setting up the live demo tiny bit, that we have an idea of what we are getting ourselves into. So I think we have the camera now as well. I think that we can start taking some questions already, and there are one or two in text, and then I will reserve those for the end.
Okay. Should I stay screen sharing in case?
Yeah, please stay as well with the screen sharing.
Okay. Yep.
Hi, Sam.
Hi there.
Thanks for the amazing talk. That was really inspirational.
Oh, cool. Thank you.
I was mostly wondering, the Unity plugin that you made, how much time does it take to make something like a basic first version and then like iteratively tweaking it? Like, how much time would something like that take?
Do you mean this implementation like for the game Gloomhaven, or do you mean me implementing the tool, the plugin and the tools?
Well, I guess for Gloomhaven it already builds on your own tool, right?
Yeah. So the tools, I mean, there was a bit of collaboration, and there was feedback from discoveries whilst making the game that fed back into changes I made to the tool, both for sort of usability and things like performance as well, which obviously came up when you actually try and use something on a full game.
So I guess mostly for the tool then.
I think so. I'd had the technology and the tooling, the sort of its own standalone editor, which you saw, were already operational, and it was. I wasn't originally planning on bringing it into another engine like Unity, but I spent some time talking to some fellow developers in various points, and it occurred to me that it might be interesting to try and use it, because primarily originally it was for geometry generation. So I thought it'd be interesting to try using it for object placement, and something like Unity would be a good place to try that. And I spent I don't know, it was probably a couple of days just writing a .NET wrapper because the appearances runtime is native, a .NET wrapper, and started plugging it into Unity as a test. And within a few days, I had it placing objects. And as soon as it was like connected, that was like, the floodgates opened, and all of the functionality I already had for all the procedural logic and building and driving it became available. And then it was really down to the time spent implementing procedures and that side of it.
Okay.
I don't know if that answers your question.
It
was kind of a bit of cheat, because I already had the technology was there. It was plugging it in. I mean, it didn't working around wrapping native stuff in and so you can expose it in .NET is a bit of a pain, but and there was a few problems with that. It's been an ongoing thing. There's loads of stuff I've had to tweak and improve and make the sort of integration better and more optimal, things like that. But yeah, and lots of interesting discoveries about how Unity works.
Okay, cool. Thank you.
Hopefully that answers your question.
Yeah, thanks.
I don't know, we've probably got time for one or two more questions. And if you feel free to contact me on Twitter or something if you want to ask more questions or see what else I'm up to.
Hey Sam, it's a really great tool that you've created there. It's really interesting and it's super responsive. That's really like an amazing aspect of it.
It's an important part of what I was trying to do.
Yeah, I mean other systems like it's a lot harder to actually get them to be as responsive as your tool there. I was wondering like how did you integrate or add in bespoke assets into your system? Because like you've got your procedural world, and then it's often quite hard to actually integrate like bespoke pieces into the procedural system.
Oh, okay. So for example, if the artists want to say, I must have this thing here, but all the rest is generated. In the case of Gloomhaven, I think originally they wanted to use, as I explained, kind of went through, it started off as just an adventure mode as a way of getting things going. And the plan was to then find a nice sort of generated version and then freeze that to be used as the sort of the bespoke, the full game campaign, and then hand edit stuff and change things. And that's certainly an approach you can take. But then you've disconnected yourself from the generative part of it, and you can't regenerate. That it depends what the artists need and want, because that gives them the ultimate control. And yes, it gives them a good starting point, particularly if you've got a system built like as it is now. But it means there's it can take a lot more time for them, even though they saved a bit of time with the actual initial starting point. They're still building a lot of stuff by hand. So that would be the ultimate way. I mean, there have been cases where I've basically hard-coded special cases into the procedures. So the crypt floor you saw with the worn center tiles and the rougher outside, and the ruined floor, those are two special cases that are switched in and that have special logic for those cases. And sometimes they use additional asset lists. So the crypt floor has I have a good picture of it. The crypt floor has little inset tile pieces, and there's all procedures for generating those as well. And that's something that all the other floor types don't have. So that was a way of incorporating something that the artist wanted to do with that particular sort of look. So there's that option as well. Some of the lists are for doing environmental effects, and so if you could basically leave blank slots in the systems that say, well, if there is an asset in this slot, I'll use it, and if not, I won't. And that means that an artist could say, well, okay, I need some of these things in this level, but only in this level. And that's another way of doing it.
Okay, cool. Cheers.
There's a variety of ways there, probably more.
Yeah, there's a lot of ways to kind of try and integrate kind of bespoke pieces into a level, but it's often quite a tricky process.
The loss of, artists are often worried about the loss of control that procedural generation brings, and it's kind of a balancing act to bring some of that back, or prove that they don't need the control everywhere, which is another approach.
Cheers.
I think
I'll put one more question there.
Are you sure we've got time? Yeah. Sure.
I think
I'll try not to talk.
I think it's one that maybe more people are curious about, and this one comes from Ivan Notarosh. The question is, can it be used at runtime? If you want to make a roguelike game and have the levels be generated differently every time, is this something that you can do with the parents?
Yes, so that's the adventure mode that they went for, is like that. It is operates at runtime. It depends. You could mean like actually live whilst you're playing and things changing, but you could do that as well if you wanted to. But for Gloomhaven, it's the adventure mode is a generated scenario. So each time you play, you get a different room layout, and all the geometry is built for that room layout at runtime. Yes. So that's another important tenet of what I was trying to do. Is it's a fully runtime system.
Okay, that's fantastic to hear. I am sure there are some difficulties there that are not easy to, some challenges that are not easy to.
Probably a whole other talk, yeah.
yeah, I can imagine bringing this to a console and stuff like that. It's extra level of work. Thank you very much for the talk and the Q&A. We do have more open questions in written form, and probably Sam will spend the next few minutes trying to answer. So he will stay with us online and hopefully answer most of your questions. And in the meantime, we will move to the next talk. So we will move to our next speaker.